Hello and welcome to this presentation on the user requirements notation, where we will look at beneficial requirements modeling with goals and processes. My name is Daniel Amyot. I am a professor in software engineering at the University of Ottawa, Canada, and it is my pleasure to be part of this ADA Europe conference. Actually, there is a bit of a connection between the user requirements notation and ADA in the form of my former co-supervisor, Raymond Buer, from Carleton University, who provided several books and other contributions on ADA in the 80s and the 90s, and then came up with this use case map notation around 1995. And the use case map notation is part of URN, together with a complementary notation for goal modeling. Unfortunately, Ray passed away earlier this year in January. So beyond use case maps, there are many process and scenario notations you are probably aware of, including BPMN, Petri nets, activity diagrams, CMMN. But beyond processes, there exist also another categories of notations for goal-oriented modeling, whether in the form of the goal-oriented requirement language, GRL, OMG's business motivation model, or CHAOS, ISTAR, and there are a few others as well. And what they intend to do is to enable modeling goals and their relationships and to reason about them. Now, the question I will try to answer in this presentation is, are there benefits in combining goals and processes for requirements modeling? And the presentation will start, first of all, with an introduction to the user requirements notation, and I will also give a demonstration based on a tool that we have developed. And we will discuss completeness and consistency analysis, first between the goal and process views of models, but also between such models and other design artifacts. And benefits and challenges will be discussed along the way. So I believe that goals and processes are complementary views in many ways. First of all, in terms of concepts, where goals try to identify the who, the where, and the what of systems, but also the why. So essentially trying to provide some rationale for the existence of some modeling or system elements. Processes will discuss the who, the where, the what, but also the when aspects that are rarely present in goal models. So those are complementary views. Also, in terms of requirements engineering usages, goals are more often discussed by managers, for example, at a strategic level, whereas processes come from people in the trenches who are able to discuss about the operational level of systems and organizations. The two views are also complementary in terms of the types of analysis that they support. For example, at the goal level, we discuss quality and stakeholder satisfaction, and also the evaluation of alternatives for design decisions and also trade-off analysis. Whereas at the process level, usually what is more common is to reason in terms of execution, simulations, tests, and performance analysis. Going back to the user requirements notation, this is something that has been developed for the past 20 years. It has been standardized by the International Telecommunication Union, ITUT, which is a United Nations entity, to explicitly address goals and processes in graphical and textual ways in one unified language. So we started with the requirements for designing the language itself around 2003. And we came up with the first release of URN in 2008 with revised versions in 2012 and 2018. And please note that the standard is also available for free online. Just to give an overview of the notation in a nutshell, the GRL view essentially discusses what we call intentional elements, which are goals, tasks, and also soft goals or quality aspects. The actors that contain them, like the system actor, a customer, and a vendor, which are essentially stakeholders to the system. Various links that connect those entities together. For example, we can have OR decomposition and decomposition. We can also have contributions. So essentially the source contributes to some extent or to some weight to the satisfaction of the destination. And this can be also negative along the way. We have indicators such as revenues here, and we'll see that indicators essentially translate physical values that are observable in the environment into satisfaction values between 0 and 100 that the system, that the URN language can understand and reason about. And finally, what we have are strategies which enable me to provide some initial values in terms of satisfactions to some of the elements, like I select the first option here, but not the second option. And this allows me to propagate this information through automated algorithms towards the other intentional elements of the models and also their containing actors. So I know that this first option here satisfies the system, but this satisfies the customer who won't be happy about this solution. So I could have multiple strategies and do some sort of trade-off analysis. We also have the use case map notation. So it's a typical process language that allows me to define essentially the sequencing of activities that we call responsibilities in use case maps. In addition to sequencing, we have obviously alternatives. We have concurrency as well, hierarchical decomposition, and also we can bind responsibilities to containing components, and we can have hierarchical structures of components. Like here, check availability belongs to a database that belongs to the system itself. We can also have scenarios, which allows us to define what are the initial contextual values for some of the variables used in the use case map model, for example, to formalize the various conditions that we are facing. So what you have in red here is essentially the result of the traversal of the model for one particular scenario. So the black part has not been visited along the way. So again, we can have multiple scenarios, essentially allowing me to test my process model and check some coverage measures, for example. Now, the URN language supports links between the goal view and the process view as well. So I can see the presence of little triangles here. So the system component in my use case map model is connected to the system actor in my goal model. So I can establish traceability between the two views. This is all supported by jUCMNav, which is an Eclipse plugin that is freely available and that I will use in my demonstration. So URN has been around for 20 years and a bit more, given that use case maps have been there for a bit longer. We realized that about 100 papers per year discuss URN in one form or another in the academic literature. And although at the beginning we designed the language to support telecommunication and networking services, what we see now is that a lot of the recent usages of URN are going well beyond telecommunications to enterprise architecture, business processes, healthcare, and also regulatory compliance. So at this point, I will give a short demonstration of jUCMNav. So this is a tool that allows me to create and analyze URN models, where a URN model is composed of a process view and also a goal view. So I have multiple diagrams that each presents a perspective or projection of the entire model. So if I look at this particular model here, I have the IMS, which is an incident management system for a hospital, whereby what we want to do is to support reviews of incident being reported by staff and visitors inside the hospital, and also to provide advanced features for detecting duplicate reports and also for finding physicians automatically that need to be part of some review committee. And the review committee needs to be effective and be efficient, whereas the hospital wants to avoid legal actions and wants to make sure that they provide high patient safety while being legally compliant. And this depends on the system being able to support reviews. So we can identify essentially various objectives and how they are decomposed by end decompositions and whether there are alternatives available. The process view provides some operationalization of this information and essentially tries to identify what are the sequence of responsibilities that need to happen. For example, the observer needs to report an incident, and the system will check for duplicate. If some duplicate is suspected, then we're going to ask for a confirmation, and depending on the answer provided by the observer, duplicate can be confirmed or not confirmed, and then this will go to a review committee. And depending on the nature of the incident, we can have a normal review or some clinical review that requires the presence of a physician along the way. Now, in addition to that, the system allows me to provide strategies and scenarios, as I mentioned earlier. So if I look at one particular scenario here, so it's a clinical incident, duplication is not confirmed, and there is only one attempt at the review. And what you have in red here is essentially the paths or the sequence of responsibilities that are being followed for that specific context. And in the diamond here, which is called a stub, which is a container for submaps, essentially this particular submap has been selected. Whereas if I use another scenario, then suddenly nothing in this clinical review will be selected, but the normal review will be selected instead. So I can execute and test different situations and see how my model reacts to it. Similarly, on the goal side, if I provide some strategies, essentially, if I do some selection of alternatives that I have in my model, then my IMS system is satisfied to 100, which is the maximum. But the impact of that selection will make the observer and the committee not very happy about it. So I can define some other global alternatives and see what kind of satisfaction this will lead to. So in here, the committee will be more satisfied, but the hospital will be less satisfied as a trade-off. So again, multiple strategies can be defined, and I can reason about which one gives me the best global solution, knowing that I cannot satisfy everybody. There are some elements also that have some triangles indicating traceability, as we saw earlier. So this is information that I can add to my model and that I can use also to navigate to various sources connected to it. So here it's connected to a goal with confirmation in my goal view. The result of my analysis can be exported. So there are many reporting facilities in jUCMNav, and one of them is quite interesting. So it's using the result of a traversal according to some scenario definition. And the result can be exported to various formats, including test cases or sequence diagrams that represent a flat view of a long trace that has been executed. URN also supports a textual syntax as well. So this is something that enables people to create models perhaps a bit more effectively, provided some textual IDE such as VS Code or others, and some auto layout mechanism will generate essentially the graphical view along the way. So we have syntax for GRL. We also have a syntax for the use case map notation. This is quite recent. This is part of the latest revision of URN from 2018. Going back to indicators, so I was saying earlier that very few people essentially can deal explicitly with a satisfaction range with abstract values from 0 to 100. So what the indicators are doing essentially is to convert some value that is being observed compared to some attributes of the indicator that essentially tells me about the target. If I hit the target, I'll be satisfied. If I hit the worst case, then I will be totally dissatisfied. And for 1300, essentially, I get something in the middle. So according to some interpolation formula that we have, the KPI returns a satisfaction of 70. So this allows me to deal with aspects of the physical world that people can understand and still normalize all of my satisfaction values into one range that URN can understand. Now, one question people may ask at this point is why not combine both notations into one? Why keep those two views separate? Well, there has been several attempts to extend, for example, goal modeling languages with sequencing operations and also process notations with some goals. But in general, the results were not great because there were issues with separation of concerns. Everything was mixed up. There was a risk of mixing different levels of abstraction as well, because goal models are usually more abstract than operational levels described with processes. And usually the result does not scale very well to complex systems. So what URN is proposing essentially is to use traceability links between those two perspectives instead. So these URN links essentially allow us to connect any pair of URN model elements, and very often they're used to connect an element from the goal view to an element of the UCM view. For example, we can have links between actors from GRL and components from use case maps, or from some intentional elements such as a task or a goal in GRL to a process or specific responsibility in use case maps. So having those links allow me to exploit them in various analysis algorithms. Also, knowing that URN can be used in many different domains, the language supports metadata that are essentially name value pairs that allow me to annotate elements with domain specific information that I can exploit during my analysis. So the benefits here are really to get into a situation where I can answer many questions using my URN model, starting with why questions from the GRL view, when questions from the use case map view, and those are rather complementary and unique to each perspective. For the what, the who, the where, this is essentially where we have some overlap and perhaps a need to make sure that the goal view and the UCM view are properly aligned together. To ensure this alignment, this is where completeness and consistency analysis become useful. And traceability will be the tool that we use here to assess whether completeness and consistency are satisfied. And some issues can be detected along the way, such as goals or process elements that are missing or unnecessary because the other view may or may not have something corresponding to it. Just to give you a simple example, I have a transportation system here that wants to bring me at work, either by bus or by bike. And each of them has some positive or negative impact on improving the health of the worker. And there is a simple process here where I have two options for the transport stub along the way. So there are some traceability links that I can establish. So the worker actor correspond to the worker component in my UCM view. And I can say that this task here corresponds to this activity here. Now, there could be some issues along the way that I can detect through those traceability links. For example, I could realize that the transportation system and the system here don't have any links. And actually, I could decide to connect them together because they really fit one another. There could be situations that are a bit more subtle in that a link that I created maybe does not really make sense. For example, I have a buy bus task here, and I have a take car responsibility here. So maybe this is something that I should reassess and probably move the link to take bus here instead. There are other types of syntactic inconsistencies I can easily detect. For example, buy bike is not linked to anything. So either I remove it, or maybe I should have another process definition by bike, take bike, for example, and connect it to it. Same thing here, take car. If I no longer have this thing here, probably needs to have either a new responsibility connected to it, or I remove this plugin altogether. Along the way, I will realize that given the fact that I'm not talking about the same level of abstraction, there are things that may not be linkable to the other view. Improve health is very abstract, right? So it doesn't have a simple operationalization. So maybe I want to say, hey, don't try to find a match for improve health. And same thing here, the leave responsibility is to find grain, so there won't be anything corresponding in GRL. So I want to identify those things as elements for which I shouldn't have any link. And this is something I will do using metadata, as we saw earlier. So I can tag those elements as elements that should not be linkable. And I can define different rules for my consistency checks, and perhaps even take a subset of those rules depending on the kind of models I'm looking into. So there are also issues along the way. So I may face situations where my model are complicated. So trying to create all the potential links to ensure traceability and completeness and consistency is just too cumbersome. So I could use the model structure to minimize the number of links and infer coverage along the way. So if I have a link to a GRL actor, I could, through transitivity, assume that all the content elements are covered as well. So this is why we have defined many rules, and we've used OCL to do that. And this is supported by jUCMNav. So jUCMNav allows people to create their own rules and to select them. And once you check those rules against the model, the tool will essentially flag violations to the various rules that were selected and identify which elements are creating those violations. And obviously we want to fix them. So the tool that we have allows people to easily add or remove the trace equal no metadata. We support some quick fixes along the way. And also traceability by construction. So if I create a new actor, then I might be asked to create a corresponding component on the use case map view. So if I go back to jUCMNav just to showcase this in 1 minute. So in my tool, I have selected many rules for this particular example. So there are a dozen rules that I have selected here. So I can now simply check those rules against my model. So 4 of these rules were violated along the way, possibly multiple times. And essentially I have the list of warnings here. And now I can decide to do something about it, right? So here it says that each GRL actor must have a link to a component. And the violating component here is the hospital. So I could tell that the hospital is not something I'm interested in. So in the process views, I will say, well, do not apply checks to that particular element. Then it is said that the physician in the use case map view does not have anything equivalent. So I could say, well, the solution here will be to create a physician actor and link it. So this is what the tool has done. So if I go back to my goal view, I can suddenly take the physician actor and bring it into my model and create appropriate concerns or objectives for that actor. There are other solutions sometimes where, thank observer in my process view might be to send something superfluous. I could just remove it and check my rules again, and suddenly I have fewer and fewer exceptions that are being raised, and I can ensure the alignment of my two views. Now we can also check completeness and consistency with other artifacts outside of the URN model itself, whether there are textual requirements or design information or regulations or code in ADA or some other language. This is not something done inside jUCMNav, so we need to rely on third-party traceability tools, so essentially requirements management systems to do that, especially those that enable some traceability analysis. So we have created mechanisms to export from jUCMNav models in such a way that they can be imported in the IBM Rational Doors requirements management system, for example. And the elements that are being imported can be then connected to other requirements and other models that have been imported in the same way to enable impact analysis, consistency analysis, and completeness analysis, just like what you would do with other requirements-based types of analysis. Another integration that we have done, which is quite interesting, is to generate code from the goal view. And this is particularly useful for adaptive systems, where the goal model essentially tries to represent the selection of features and activities on the fly based on some monitored context. So what we have done is to provide an arithmetic semantics for goal models, so we can generate a function for a goal model. And this is automated in jUCMNav via a Python library called SymPy that allows us to generate code in 7 languages. So ADA is not yet supported, but that's something that would be fairly easy to add along the way. And once we have those functions generated, then they can be used and embedded into larger design models in SysML or AADL and others, enabling simulation or optimization. So we have used IBM CPLEX in that context, and also in the implementation itself. So we can embed code that would drive adaptive systems automatically. So there are many benefits in exploiting traceability links between goals and processes, and this is practical, and this essentially allows us to establish and maintain alignment, consistency, and also compliance. So we have ways to capture regulatory information and laws as URN models as well, so we can essentially create traceability at that level and use it during analysis. And the functions generated from GRL are also quite versatile for spotting different types of analysis and eventually implementations. There are challenges at that level. So creating traceability links is still very manual and onerous and quite boring. There are some potential ways of using natural language processing, for example, to create some of these links automatically and reduce the manual labor along the way. We still have some issues in finding semantic issues in existing traceability links along the way, as discussed earlier. The syntactic ones are a lot easier to automate. So in conclusion, goals and processes are complementary and synergetic. URN combines both views with links connecting them. Traceability enables many useful types of analysis, including consistency and completeness and alignment in general, and not just for telecommunication systems, so for any types of systems. And this brings important benefits in having both views for supporting system development, especially to avoid missing important requirements along the way. Now, there are still many challenges left to explore, and this is an invitation for more contributions from your community. So thank you for your attention. So I'd like to recognize the efforts of my students, current and past, for the past 20 years, and also many co-authors and collaborators over the years. This has been funded by many organizations, including some private companies along the way. So I would like to thank the AEiC 2021 organizers and US participants for listening to this talk. So please do not hesitate to contact me should you have any question. Thank you so much.